It's a silent observer in our homes, a constant companion in our cars, a gateway to a reverse reality. You look at it every single day, check your hair, maybe try on an outfit. It seems so simple, almost magical, how it flawlessly copies everything in front of it. But what if the very thing you think is doing the work isn't? What if the secret to its perfect image lies hidden just beneath the surface? It's not just about shininess. The true story of reflection dives deep into the unseen world of light and atoms, revealing a meticulous dance of physics and a stroke of engineering genius. Welcome to the Smart Side, the channel where we unravel the hidden science behind the everyday. Let's set the stage with light itself, made of tiny packets of energy called photons. When these photons hit an object, they face a choice: be absorbed, pass through, or bounce off. Now, most surfaces you see, like this desk or your clothes, they do reflect light, but they reflect it diffusely. Imagine a bumpy field. If you throw a ball onto it, it'll bounce off in all sorts of random directions. That's diffuse reflection. But a mirror? A mirror is a master of specular reflection. Think of a perfectly calm, still lake. If you skip a stone across that mirror-like surface, it bounces off neatly and predictably. So how does a surface achieve this perfect organized bounce? This is where our story takes its surprising turn into the not-what-you-think territory. Most of us assume the transparent glass on the front is doing all the work, but in reality, the glass is mostly a protective shield. Its main job is to provide a perfectly smooth stage for the real performer, a microscopically thin coating of metal. For centuries, mirrors were just polished metal, often silver. Today, our mirrors use either silver or aluminum, vaporized and coated onto the back of the glass. And here's why these metals are the true unsung heroes. They have a unique atomic structure. Their outermost electrons aren't tightly bound to individual atoms. Instead, they form a kind of sea or cloud of free-moving electrons, ready for action. Now, for the truly astonishing part, a ballet that happens at the quantum level, faster than you can possibly imagine. When a photon of light arrives at this bustling sea of electrons in the silver or aluminum, it's not simply bouncing off. Instead, the photon is absorbed by one of those free-moving electrons. This absorption instantly gives the electron more energy, causing it to briefly jump to a higher energy state. It gets excited. But here's the crucial twist. That excited electron is unstable. It almost instantaneously, we're talking femtoseconds here, quadrillionths of a second, releases that extra energy by re-emitting another photon. And here's the magic trick. This newly emitted photon is identical to the one that just hit it, and it zips off in the exact opposite direction at the exact same angle it arrived. So it's not a simple bounce like a tennis ball off a wall. It's light being absorbed and then immediately reborn and perfectly redirected, all thanks to the unique, eager electrons in that ultra-thin metallic layer. So, if our metallic heroes are doing all the heavy lifting, what's the role of the glass? Well, it's the transparent bodyguard. It acts as a perfectly smooth, stable stage for that delicate metallic layer, and more importantly, it shields that crucial silver or aluminum from scratches, moisture, and corrosion. Without the glass, your mirror would quickly tarnish and lose its brilliant reflective power. This layered structure also explains how two-way mirrors work. They use a much thinner layer of silver or aluminum, a kind of semi-transparent film, allowing some light to pass through while still reflecting some. The illusion depends entirely on the light levels on either side, and that dull gray or sometimes greenish paint you see on the very back of a mirror, that's another vital protective layer, doubling down on safeguarding the metal from air and moisture that would otherwise degrade its reflective properties over time. It's a hidden shield for the hidden hero. So, the next time you glance in a mirror, pause for a moment. You're not just looking at a shiny surface. You're witnessing an incredible invisible dance happening at the atomic level. It's a meticulously engineered optical device where light photons are absorbed and then perfectly re-emitted by a vast, eager sea of metal electrons. A seemingly simple object hiding complex quantum physics and a surprising story. Or were you surprised by the true science behind mirrors? What other everyday magic would you like us to explain on the smart side? Share your most perplexing questions in the comments below. If you found this explanation enlightening, smash that like button, share it with a friend who loves hidden science, and make sure to subscribe to The Smart Side for more mind-blowing discoveries. Because the more we understand the world around us, the more incredible it truly becomes.